navigate to a website and press enter, the physical mechanism of your keyboard clicks into place. Most of us expect the resulting page to appear in under 3 seconds. In reality, having that data arrive so quickly is an engineering feat that relies on precise coordination across the entire planet. To see how this works, we can freeze time at the exact millisecond this key bottoms out, and trace the journey required to pull a website onto your screen. This physical click starts a chain reaction that moves from your local hardware to distant servers and back through a series of specific checkpoints. The journey begins with a hardware interrupt. Your keyboard sends an electrical signal to the operating system, which immediately passes the keystrokes to your active web browser. The browser's address bar, the Omnibox, must instantly decide if you've typed a search term for a search engine or a specific URL address that it needs to locate directly. Before reaching out, the browser checks its preloaded security registry, the HTTPS list. This determines if the site requires a strictly encrypted HTTPS connection from the very first packet. Your browser has already executed a series of internal logic gates to determine what you want and how to ask for it safely before a single signal leaves the building. Every website has a numerical IP address. Your browser, operating system, and local router first search their own internal caches to see if they already have the location stored from a previous visit. If the address isn't found locally, the request travels to your internet service provider's recursive DNS resolver, which takes over the hunt. The resolver starts a recursive lookup, querying the global root name servers. The root directs the resolver to a top-level domain server for .com addresses. Finally, the TLD points to the authoritative name server, which provides the exact numerical IP address and returns it. This global hierarchy allows the internet to translate human-readable names into the strict numerical addresses required for routing data across the network. With the address in hand, your computer initiates a TCP three-way handshake. The sender and receiver exchange synchronize and acknowledge messages to establish a reliable line of communication. Next comes the TLS handshake. The client and server exchange digital certificates and generate a set of cryptographic session keys. These combined negotiations ensure the connection is private and encrypted before any specific website data is actually transmitted. By establishing these rules of engagement first, the internet prioritizes secure routing and verifiable trust over raw delivery speed. Now your browser sends an HTTP GET request over the secured line. The server processes this and sends back the raw HTML payload for the page. The browser's rendering engine parses this text to build the Document Object Model, or DOM, a structural blueprint of the entire site. The browser then applies CSS style rules, fetches images, and instructs your local GPU to paint the calculated layout onto your screen. The finished page you see is a live construction, assembled from individual code fragments using your own device's processing power. As we unfreeze time, this entire sequence, from hardware interrupt to painted pixels, has just concluded in less time than it takes to blink. The density of this data is increasing. The average web page has grown to 3 megabytes, and those sizes continue to expand as sites become more complex. To manage this, developers use performance budgets, carefully optimizing images and fonts to ensure load times don't balloon as page sizes grow. This delivery depends on a massive physical infrastructure of fiber optic cables, subsea lines, and specialized data centers. Every time we navigate to a URL, we are utilizing a global network that requires constant, silent coordination between physical hardware and software logic.